Good morning, good afternoon, everyone. My name is Maurizia Seggiani, and I'm from the Department of Civil and Industrial Engineering at the University of Pisa, Italy. It's a great pleasure for me to take part in this summer course, and I'd like to sincerely thank the University of Mataram and the Hasanuddin University for their kind invitation. Well, in this occasion, I'll give you a lecture of training waste management in Europe within the framework of the Erasmus Plus LHTech project, which is focused on enhancing sustainable and green leather technology in Indonesia. And the LHTech project brings together Indonesian and European partners, including EG University from Turkey, the University of Pisa from Italy, the National Technical University of Athens, and the Cretidev from Greece, and SGS from Italy. Well, in this lecture, I'll first introduce leather as a natural, bio-based and durable material. And I will briefly explain why leather can be considered sustainable when it's produced and managed correctly. And then we will look at the European trend in tanning industry, with particular attention to the Italian tanning sector and to the Tuscan leather district of Santa Croce sull'Arno, which is one of the most important examples of an integrated tanning district in Europe. And the central part of the lecture will focus on the tanning waste management, and I'll give you an overview of main types of solid waste and animal byproducts generated during leather and processing, and how they can be recovered and transformed into valuable products such as fertilizers, biostimulants, collagen, gelatin, and even materials for construction. After that, we will move to tannery wastewater management, and I will also present some examples from the Italian experience, especially consortial treatment plants such as Aquarno, Cuoio Depur, and sludge treatment plants and chromium recovery systems. Well, these examples show how waste and wastewater from the tanning sector can be managed not only as an environmental problem, but also as an opportunity for circular economy. So let's begin with the first question. What makes a leather such as unique material? As you are well informed, leather is a natural and renewable material based on collagen fibers, which by the tanning process becomes incredible versatile, both functionally and aesthetically for numerous product uses. It's, it's also breathable, but at the same time insulating, and if necessary, can be made waterproof. And for this reason, it boasts numerous attempts and imitation, which, however, fails to replicate its stylistic and technical and performance properties. Why leather can be considered sustainable? More than 99% of the raw hides and skins used by the tan industry came from cattle, sheep, and goats. And these hides and skins are not the main product. They are byproducts of the food industry. And in Europe, they are classified as animal byproducts or ABPs. And tanneries recover them and transform them into leather instead of letting them to become waste. And this recovery activity is very important. Every year, the tan industry recovers millions of tons of hides and skins worldwide. And if these materials were not used, they would need to be disposed of, creating additional environmental impacts and greenhouse gas emissions. So leather comes from materials that already exist as a byproduct. And the tan industry gives this material a second life and turns it into a durable and high-value product. And here I'd like to underline a very important message. Animals are not killed for their hides and skins. Well, so leather production is linked to the recovery of byproducts from the food chain. Well, other reasons why leather can be considered sustainable. Leather can replace synthetic materials, many of which are derived from fossil resources such as the PVC or polyurethanes, and are not easily biodegradable. And during leather production, several residues are generated, but many of them can be recovered and reused. For example, they can be used in agriculture, in construction sector, in cosmetics, food, and other sectors, as I'll show you. And the leather is also a bio-based material. It's mainly made of collagen, which is an organic and biodegradable material. Finally, leather is durable. This means that leather products can have a long service life, both in terms of functionality and appearance. A longer life cycle means fewer replacements and consequently a lower consumption of resources. Well, for these reasons, leather can be seen as a material that fits well into a circular economy approach on conditions that the production process is carefully managed from an environmental point of view. Well, so in the last years, various tanning industries, such as Italian tan industries, have decided to communicate its values, goals, activities, impacts, and results using the Sustainable Development Goals defined by the United Nations in the 2030 Agenda. And for this lecture, some goals are especially important, such as clean water and sanitation, because wastewater treatment is essential in tanning. The industry, innovation, and infrastructure, because sustainable leather production requires new technologies, new infrastructures. Responsible consumption and production, because tanning must be linked to the recovery and valorization of byproducts of wastes. And about the climate action, because energy efficiency and emissions reduction are increasingly important in the tunnel industry. And I'd like also to highlight partnerships for the goals, the last goal, because these summer course and the Elegitech project are excellent examples of international cooperation between Europe and Indonesia. So, when we speak about tiny waste management, we are not only discussing waste treatment, we are discussing how an industrial sector, as the tanning sector, can contribute to a more sustainable global model. Well, this slide presents an overview of the European tanning industry. The map shows that leather production is spread across several European countries, with Italy clearly standing out as the leading country in terms of turnover and employment. And Spain, France, Germany, Portugal, and the UK also play an important role in the sector. And overall, the European tanning industry produces about 160 million square meters of finished leather, confirming its economic and industrial relevance. Well, so in this slide, you can see the main destinations of European leather. Footwear is the largest market, followed by leather goods such as bags and accessories. Other important sectors are shown in this slide. And the lower section also shows that European tanning production is mainly based on bovine leather, which accounts for 80%, followed by sheep and goats leather at 90%, while exotic leather represents only 1%. Well, after this general overview of the European tanning industry, let's now focus on Italy, which represents one of the most important countries in the European and global leather sector. Well, Italy plays a leading role in the tanning production, both in terms of quality and economic value. As shown in this slide, in 2024, the Italian tanning industry included 1,000 companies with a total turnover of about 4 billion euros. In terms of production, Italy produced about 95 million square meters of finished leather and about 8,000 tons of sole leather. And these productions corresponds to approximately 67% of the total European production and 25% of world production, which clearly shows the strategic importance of Italy in this sector. Well, I'd like to focus also on the Tuscan tanning district of Santa Croce Sull'Arno, which is the largest tanning district in Italy and one of the most important districts in Europe. This district is located in Tuscany between Florence and Pisa, covers an area of about 300 square kilometers. It includes around 500 enterprises and employs approximately 6,000 people. And this district accounts for about 30% of Italian leather production and almost 98% of Italian sole leather production. What makes Santa Croce Sull'Arno particularly interesting for this lecture is not only its production capacity, but also is a strong circular economy model. Here, water and waste materials are recovered, transformed, valorized, and reused by dedicated consortial plants. In fact, the district includes wastewater treatment plants such as Acquarno e Cuoio Depur, a chromium recovery plant, and treatment plants for shavings and fleshings. Well, after introduce the Santa Croce sull'Arno tanning district, we can now focus on the main types of solid waste generated during the tannery process. This slide shows the origin of these solid wastes along the different production steps. In fact, well, in the first phases, such as soaking and liming, the hydes are prepared for tanning, and the hair and other organic residues are removed, generating lime sludge and other biodegradable organic waste. And then during fleshing, the subcutaneous tissue and the fat are mechanically removed from the underside of the hide, and this produces fleshings which are rich in organic matter and can be recovered for several applications. And in the following steps, such as splitting and shaving and trimming and cutting, other residues are generated, including split scraps, leather shavings, and trimmings. And some of these materials may contain chromium, especially when they are produced after chrome tanning, and consequently they required specific management. Finally, during bathing and finishing, very fine dust is generated, and this type of waste may contain resins and pigments, dyes, or other finishing chemicals. So it must also be properly collected and treated. So tannery solid wastes are very heterogeneous, and their composition depends strongly on the stage of the process in which they are produced, they are generated. And for this reason, correct separation and classification are essential for their recovery and final valorization or for their correct disposal of. Well, now I show, give you some data about the situation of the West in the Italian tannery industry. Because as it shows, several types of residues are generated during leather processing. And this slide gives us a quantitative view of this issue. Less than, because less than 30% by weight of raw hides is converted into finished leather, and their remaining materials is removed during the different processing steps and becomes waste, byproducts or animal byproducts. However, it's important to underline that most of these materials is not simply disposed of. In the Italian tanning sector, more than 72% of the waste produced is sent to recovery plants, while only a smaller fraction is destined for disposal, for landfill. Well, some residues from the preparation phases, such as fleshings, are classified as animal byproducts. And these materials can be transformed into biostimulants and fertilizers for agriculture, or into gelatins and other products for the food and pharmaceutical sectors. Other residues, such as trimmings, shavings, and leather scraps, can be used to produce regenerated leather fiber board or fertilizers or other recovered materials. So this slide is important because it shows that waste management in the tanning sector is not only about treatment and disposal, but is about recovery, reuse, and transformation into new resources, new products. Everything is connected, everything can be transformed. In fact, this slide introduces the central concept of a circular bioeconomy in the tanning sector. The idea is that everything is connected because the food industry produces hides and skins as byproducts. Tanneries transform them into leather, and the residues generated during leather production can be further recovered and used in other sectors, as shown here: fertilizers, biostimulants for agriculture, gelatins and collagen for food, cosmetics, pharmaceuticals, and so on. Okay, or inert aggregates and bituminous conglomerates for the construction sector. So everything is connected and everything can be transformed. Here you can see a concrete example of a waste valorization in the Santa Croce Sull'Arno district, the hydro treatment plant. Well, this plant treats two important types of tannery residues, of tannery byproducts: fleshings and leather shavings. And the process includes several steps. First, the materials undergoes alkaline hydrolysis, which break down the organic matrix and lets the recovery of useful protein fractions. Then the materials is sterilized and treated in the decalcination section, concentrated, and finally separated using centrifuges or decanters. And the final product include organic fertilizers, concentrated protein broth, and technical grease. And in this way, residues from the tanning process are transformed into valuable secondary products. And this is very clear example of a circular economy applied at industrial scale. Instead of sending these materials to disposal to landfill, the district is able to recover them, process them, and reintroduce them into different value chain. Well, in fact, these collagen hydrolysis in liquid or powder form are already used in agriculture, mainly as organic nitrogen fertilizers and biostimulants. But a different use can be explored, in fact. collagen hydrolysis can also be used in a different and more innovative way, because collagen hydrolysis can be explored as components in the bioplastic blends due its good processability by extrusion to produce biodegradable and compostable products used in agriculture, such as pots and small containers and mulch films. In fact, so you can see that the idea is to combine a bioplastic matrix such as the PBSA, polybutyl succinate coadipate, with collagen hydrolyzed from tannery and biochar, producing pellets by extrusion that can then be processed by blowing extrusion to produce biodegradable mulching films for agriculture. And these films can be used in the field like conventional mulching films, but with an important advantage, because they are designed to be biodegradable in soil. And in addition, thanks to the presence of collagen hydrolyzed and biochar, they may also release nutrients and improve soil fertility. Well, now we move to another key environmental aspect of the tan industry, the water. Because water, after raw hides and skins, is the most important raw material in the tanning process, because yes, in this slide you can see the consumption of water for 1 square meter of a finished leather. It's used in many steps of the process, and as a consequence, resultant tannery wastewater can contain organic matter, suspended solids, and sulfides, and chromium, and nitrogen compounds, salts, and other pollutants. And for this reason, wastewater treatment is essential to reduce environmental impacts and to make the tanning process more sustainable. And the wastewater generated must be properly purified to remove pollutants and return water that is compatible with environmental ecosystems. Well, in this slide, you can see the main phases of the tannery wastewater treatment. Well, tannery wastewater is a complex because it can contain many pollutants. Okay, chromium and sulfides, suspended solids, organic matter, and so on. And for this reason, it cannot be discharged directly into the environment, but it must be properly treated. And wastewater treatment is usually based on a combination of different steps. So the first one is mechanical treatment. Mechanical treatment which removes coarse solids, fats, oils, and suspended matter. And then physical-chemical treatment is used to oxidize sulfides and to precipitate chromium and to remove part of the organic load by coagulation and flocculation. After that, biological treatment uses microorganisms to degrade biodegradable organic pollutants and to reduce the COD, chemical oxygen demand, and BOD, biological oxygen demand. And finally, we have biological nitrogen removal. This treatment is applied to reduce nitrogen compounds by nitrification and denitrification. Okay? Well, so in this slide, you can see also some important precautions. One is that the sulfides containing effluents must be carefully managed because under acidic conditions they can generate toxic hydrogen sulfide gas. Another point is that chromium containing effluents should be separated whenever possible in order to recover chromium and recycle it back into the tanning process. Finally, tannery wastewater can vary significantly in both volume and composition. So treatment plans required equalization, monitoring, and careful process control. Well, let's start from mechanical and physical chemical treatment. Well, mechanical treatment represents the first step of wastewater processing. Its main goal is to reduce the solid and organic load before the water enters the biological treatment phase. And this is achieved by several operations, including screening to remove coarse materials like pieces of skin and leather fibers, and the separation of a primary sludge, skimming of fats and oils, and gravity settling. And these steps are essential as they can remove up to 30–40% of suspended solids and reduce the COD by up to 30%. Mechanical treatment is a crucial step in protecting the rest of the treatment plant from clogging, damage, and operational issues. And it's widely applied in all modern wastewater treatment plants across Europe. And well, physical chemical treatment involves sulfides oxidation from beam house effluents and the chromium precipitation and flow equalization and the physico-chemical treatment for the COD removal and balancing. Well, here you can see a typical scheme for physical chemical treatment where chromium recovery is used, and it's usual to treat chromium contain effluents separately from beam house effluents. Well, about the sulfide removal. Sulfides, exactly sodium sulfide, are used during the beam house operation, mainly for hair removal, softening and opening of the dermal structure in combination with lime. And sulfide removal from ternary effluents can be achieved by catalytic oxidation, typically using manganese salts, which convert sulfides into thiosulfide and partially into sulfides. And thiosulfides can further decompose into sulfur and sulfides. And for this reason, in order to improve the oxidation, we can use hydrogen peroxide, but however, it's costly and usually combined with manganese or iron salts to reduce odors. And an alternative method is the precipitation with iron, salts, and aeration, forming iron hydroxide and sulfur. And this produces a brown sludge, which also removes organic matter. Among of these, the most common method in the tanneries is the catalytic oxidation with manganese sulfide. Well, about the precipitation of chromium, chromium-3 precipitation is a relatively simple technique and is more efficient if it's carried out in separated effluents after screening. And the precipitation of chromium is achieved by increasing the pH to above 8 using an alkali such as sodium hydroxide or sodium carbonate, and the chromium and the other metals are precipitated as insoluble hydroxides, and after precipitation, the chromium hydroxide is solubilized using sulfuric acid, so it's recovered as a solution of a basic sulfide of chromium. Well, flow equalization in wastewater treatment is the process of managing and controlling the rate at which wastewater enters a treatment system. It aims to reduce flow rate variation and fluctuation, assuring a more consistent and manageable flow for downstream treatment processes. This is achieved by storing wastewater during peak flow period and releasing it at a more controlled average rate. Well, about the COD removal. Well, a substantial portion of COD and suspended solid can be removed by coagulation and flocculation. And to optimize removal, the effluent pH must be controlled for maximum effectiveness of coagulants and flocculants. And after adjusting pH and allowing settling, coagulations like aluminum sulfate and ferrous sulfate and polymer flocculations are added to form flux that settle well and capture residual organics and inorganic substances. Well, here we focus on the biological treatment of ternary wastewater, which is usually applied after mechanical and physicochemical pretreatment. And this process uses microbial activity to degrade organic pollutants, and we can have aerobic treatment, especially activated sludge is the standard option, while anaerobic treatment can use it to reduce sludge production and contribute to COD removal. The choice between on-site and off-site treatment depends on local conditions and retention time and energy consumption. Well, about the biological nitrogen elimination, this is an important step when wastewater contains ammonium compounds, for example, from delimine or dine or protein residues from the beam house. And the process is mainly based on three stages. Ammonification, where organic nitrogen is converted into ammoniacal nitrogen. The nitrification, where ammonium is oxidized to nitrite, and then nitrate under aerobic conditions, and then the denitrification, where nitrate is converted into nitrogen gas under anoxic conditions. And specialized nitrification and denitrification bacteria cultures are used to improve nitrogen removal and control unwanted emissions such as hydrogen sulfide. Okay? Due to time constraints, I will not go through all the details of this slide and next slides, but I invite you to take a moment to look at them independently. Well, raw wastewater still contain a lot of easily biodegradable organic carbon, which is useful for the nitrifying bacteria. This saves carbon, no external addition is required. Consequently, the typical modern plants used in Europe uses a pre-denitrification step in order to avoid external addition of carbon, as shown in this slide. Well, at the end of the wastewater treatment, suspended solids must be removed, and the sludge produced during the process must be managed. Well, sludge can come both from the tannery and from the wastewater treatment plant. And it's first separated by sedimentation or flotation, then concentrated and dewatered using filter press, belt presses, or centrifuges. And the aim is to reduce the water content in the sludge, making sludge easier to handle, transport, and treat. And so, in some cases, as in the Santa Croce Sull'Arno, in the Ecospanso plant, thermal treatment can be used to reach a much higher dry solid content. So, sludge handling is a key final step in the wastewater treatment. So, after presenting the main wastewater treatment methods, I'd like to show you briefly how these concepts are applied in practice in the Santa Croce Sull'Arno district. In fact, in this district, as I said here before, environmental management is organized by consortial plans. And some of these plans were visited by your professors and students of your university in July last year. Well, the main activities in these plans include wastewater purification, sludge treatment, and chromium recovery. These integrated systems is one of the reasons why the district of the Santa Croce Sull'Arno is considered an important example of a circular economy in the tanning sector. Well, here you can see the characteristics, the compositions of the wastewater entering the Acquarno treatment plant. The plant, in fact, treats both municipal and industrial wastewater, but the two streams are very different. Industrial tannery wastewater has much higher values of COD, suspended solids, ammonium, chlorides, sulfides, and chromium. And this explains why tannery wastewater requires specific and advanced treatment technologies. Well, here you can see the Acquarno wastewater treatment plant. Acquarno, which is 2 million inhabitants equivalents, has one of the largest treatment capacities in Europe. And further expansions are planned over the next 10 years. Here you can see the Acquarno wastewater treatment plants that treats about 1.5 million of cubic meters yearly of municipal wastewater and about 5 million of cubic meters of tanning wastewater, recovering 6 million of clean water that is returned to the water bodies. And the resultant sewage sludge produced in the municipal and industrial wastewater plants are thickened and in thickening tanks and then pumped to the thermal treatment plants by a dedicated sludge pipe in order to produce about 7,500 tons annually of inert material for use in the construction sector. Well, here you can see the scheme that summarizes the main treatment lines of the Acquarno plant. Well, the industrial line includes screening, grit removal, homogenization, and sulfide oxidation, biological oxidation, denitrification, tertiary treatment, and sludge handling. Well, the municipal line is simpler, but it's integrated with the overall treatment system, and the final treated water is discharged into the river Usciana only after meeting the required legal limits. Well, here you can see the the thermal sludge treatment plants. Well, in this case, Acquarno sludge is conveyed through a dedicated sludge pipe to the Ecospanso plant, and the treatment process includes the dehydration, drying, and the sintering, and energy recovery, and the fumes, and the gas treatment, and the final product is a sintered inert material that can be used in the construction, in the bituminous materials for roads. Well, this is another example of waste valorization and the circular economy. Well, here you can see the Cuoio Depot is another important wastewater treatment plant in the district of the Santa Croce Sull'Arno. I like Acquarno Cuello Dapur mainly treats wastewater from vegetable tanning processes. So the wastewater doesn't contain chromium in this case, and the plant treats both industrial and the civil wastewater and produces dried sludge that can be used for agronomic applications, contributing to soil fertility and crop productivity. So finally, this slide shows the consortial plant for chromium recovery. And so in this case, exhausted chrome tanning bats are collected and treated in order to recover chromium as a reusable product. And the plant processes about 90,000 tons annually of exhausted chrome bats and recovers about 86 and 90% of the chromium, and the recovered chromium is recycled back to tanneries, reducing both chromium discharge and the consumption of new tanning salts. This is another clear example of a circular economy applied to the tanning industry. So, to conclude, the main message of this lecture is that the tanning industry can move toward a greener future by reducing waste and, above all, by transforming waste into resources. And I hope this lecture can be for you a useful overview of tanning waste management in Europe and in Italy, special way. And before closing, I've prepared some questions to help you review the main topics of this lecture. So these questions can be used either for discussion or as a short self-assessment activity. And so thank you again, and well, see you in Indonesia. Thank you very much for your attention.